This is a typical vector problem. It says a hockey player hits a puck twice, causing it to make two displacements. The first goes for 12 meters at an angle of 60 degrees with respect to the positive x-axis. The final displacement of the puck has a magnitude of 20 meters at an angle of 45 degrees, and it says find the magnitude and direction of the second displacement. So we're given the first and we're given the final, but we don't know the second displacement, and that's what we're asked to find. So the first thing to do is probably to draw a picture to get an idea of what's happening. So let's draw our axes here. Okay. I'm only going to draw the first quadrant since that's where stuff is taking place, really. X and Y. Okay. So let's call the first displacement vector A, and we'll say it looks something like this. Okay. Maybe it's like that. The arrow's on. Let's label it. Alright, let's call the final displacement vector C, and we're given that one. It says it's 20, so it's a little longer. That's at 45 degrees. So this is C. And now what we're asked to find is vector B. Well, we know that the two displacements together, A plus B, is going to make the vector C, right? Because we're just going to add them. So it's going to look something like this. Alright, so this is what we'll call B. We have the relation that A plus B is equal to C. Alright, so B is what we don't know, so we have that B is equal to C minus A. So all we have to do is calculate the components of C and the components of A, and then we can find B. Now the problem asks for the magnitude and direction, but we can get that once we have the components. So I think the first step is to get the components. Alright, let's do that. So the way to do that is to just basically draw these triangles and calculate what the components are. So A is a vector that looks something like this. Okay. So we need to figure out this side and then this side. Alright, well, we're given the angle here. Namely, this is 60 degrees. And we know the length of this side, right? It's 12. So if this is A sub x and this is A sub y, then we have that AX is equal to 12 times the cosine of 60 degrees. And AY is equal to 12 sine of 60 degrees. Alright, and we can calculate what these are, and we find, let's just save it over here, AX is equal to 6 meters, and AY is equal to 10.4. Alright, now we can do the same thing for the vector C. So C looks something like this. Okay. This side is 20. This is C sub x, C sub y, and this angle here is 45 degrees. So Cx is equal to 20 times the cosine of 45 degrees, and Cy is equal to 20 times the sine of 45 degrees. Okay, and you can calculate that. Just put it in your calculator, and you get that Cx is equal to 14.1 meters, and Cy is equal to also 14.1 meters, because we know that the cosine of 45 and the sine of 45 is the same number. It's root 2 over 2. Now we're ready to calculate what the vector b is. So we have here that b is equal to c minus a. So we get that this is equal to, well, the vector c is 14.1, 14.1, and then minus 6, 10.4. Alright, so this is equal to 8.1 and 3.7 meters. So in some sense we're done, right? We have the vector b. This is b. It's its components, and it makes sense. It agrees with the picture we drew, right? It's like 8.1 this way, 3.7 in the y direction. It looks about right, so that's good. The problem asks us, though, to find the magnitude and the direction. Right, so these are, we can get these quantities easily once we have the components. The magnitude of b, right, we draw it like this. What's going to be the square root of the sum of the squares of the components? So it's going to be the square root of 8.1 squared plus 3.7 squared. And this is equal to 8.9 meters. Okay, so that's one of our answers. And then the angle, theta, we have the formula that this angle will be the inverse tangent of the y component over the x component. Now, how do we know this? Let's draw a little triangle over here to remind us. So this is our vector b. Okay. Okay, so there's b. And this is the angle theta. And this is by over bx, and then bx. So we're interested in finding theta, and we have here, just doing basic trigonometry, that the tangent of theta, well, it's equal to opposite over adjacent, so it's equal to by over bx. And then you just take the inverse tangent, and you get this. Theta equals the inverse tangent of by over bx. And we can plug in our numbers. So this is the inverse tangent of 3.7 over 8.1, and this is equal to 24.6 degrees. Okay, and then we're done. So we have the magnitude and the direction of this second displacement.